The Mesozoic Era, the age of the dinosaurs. But how long ago was that? What is an era? How did dinosaurs become dominant? And most importantly, where did they go? First, I have to talk about geological time. Rocks are laid down one on top of the other over time, generally speaking. Tracing these is called stratigraphy. This is not so easy, as sand in a desert may be deposited at the same time as coal forming in a swamp, while mountains are being eroded away somewhere else. The two main tricks geologists have are biostratigraphy and chronostratigraphy. Biostratigraphy involves the use of fossils, but only a few qualify. They have to be abundant, turning up almost everywhere. They have to be distinctive, unlike anything else. And they have to be short-lived, existing for only 1 or 2 million years before becoming extinct. Fossils like this do exist, and they are called index fossils. Forams, ostracods, conodonts, graptolites, just to name a few. All can be used as index fossils. While very successful, they evolved rapidly into many strange and distinctive forms, many species only sticking around for a short time. Using these, geologists can link many different sedimentary rocks from across the world. Chronostratigraphy is the process by which dates are obtained. Carbon dating uses the decay of carbon atoms to determine the age of archaeological material, but becomes iffy for ages over 50,000 years or so. In geology, you need something a little more long-lasting, mainly potassium argon and uranium lead. This is used for igneous rocks, the molecular structure setting in the crystals, and their decay clocks start ticking. There is a margin of error, which is why you often see ages like this, denoting how accurate the date is. The size of these margins are all over the place based on the material you are measuring and what decay element you are using. Since before these techniques, geologists have noticed differences in the rocks and began classifying them. Major changes in how the rocks looked or what fossils were in them helped boundaries to be set. Some of these boundaries are still used today and act as the defining turning point, with an associated biome for biostratigraphy and an igneous body for chronostratigraphy. These places are known as Global Boundary Stratotype Sections and Points, or GSSPs, but they are often referred to as golden spikes. Some actually have a spike stuck into the boundary, but most just have a little white line painted onto the boundary. Boundaries with a location like this are often marked like this. And what about those classifications? First, eons. The most recent and relatively shortest eon is the Phanerozoic. It covers most of the history of complex life, about 541 million years ago to now. Next, there are the eras. The Phanerozoic eon is split into 3 eras, the middle of which is the Mesozoic, which lasted from 251.902 million years ago to 66 million years ago. Then there are the periods. The Mesozoic era is split into 3 periods, the Triassic, Jurassic, and Cretaceous. Each of these is split further into epochs. This gets complicated for most other periods, but for these 3 it's easy. For the Triassic and Jurassic, you've got lower, middle, and upper. For the Cretaceous, it's even simpler with only lower and upper. And finally, we have the ages, 30 in total for the Mesozoic era. So, eon, era, period, epoch, and age. These are the classifications of time. If you're talking about a rock sequence, you use ionotherm, erotherm, system, series, and stage. Basically, the Morrison Formation is part of the Jurassic system, but deposited during the Jurassic period. Now let's talk about the Mesozoic era itself. The Mesozoic era began about 251.9 million years ago with the worst mass extinction the world has ever seen. It's impossible to know how many died and exactly how many species became extinct. Not a single group escaped unscathed. This loss of life is obvious in the fossil record and is known as the PT mass extinction, or the Great Dying, marking the border of the Permian and Triassic periods. About 70% of land species went extinct. Most of the anapsids, a once diverse type of basal reptile, were gone. There also was the largest known extinction of insects. In the seas, about 96% of species went extinct. Blastoids, a type of echinoderm, acanthodians, a group of jawed fish, eurypterids, large predatory arthropods, and the trilobites, a leading life form for over 250 million years in the old Paleozoic seas, all gone. In total, about 83% of all genera went extinct. Signs point to low oxygen levels and high carbon dioxide and carbon monoxide, warming the land, acidifying the oceans, and preventing seawater from absorbing oxygen. This is also when plate tectonics had driven all land masses into a supercontinent called Pangaea. This created a huge amount of land far from the sea, leading to massive areas of desert and less life-rich shallow seas. As usually happens with a mass extinction, some have looked around for evidence of an impact from a bolide, an extraterrestrial body like a comet or asteroid. No evidence for an impact has been found close to this time. The most likely main cause of this event is the Siberian traps, flood basalts that cover about 2 million square kilometers now, but indicate volcanic activity over 7 million square kilometers, releasing 4 million cubic kilometers of lava. This activity released an estimated 85 million tons of carbon dioxide, 68 million tons of sulfur dioxide, creating acid rain, 7 million tons of hydrogen sulfide, killing plants and depleting the ozone layer, and 4.4 million tons of carbon monoxide. The world was left dry, with hot days and cold nights. It was highly seasonal and spotted with lush areas around sources of water. There was no grass or flowering plants. Conifers were common, but most abundant were cycads, ginkgos, and giant ferns and horsetails. Extinction is not necessarily bad for everything. The creatures that survive have a lot of space to move into once recovery begins. The Triassic was full of evolutionary innovation. The mammal-like reptiles were taking the opportunity to become more mammalian, while the archosaurs were trying to nab every available niche they could. Tree climber, covered. Armoured herbivore, covered. Huge top predator, way covered. They also took to the skies as pterosaurs. A related group of reptiles also took to the water. It was from these archosaurs that the dinosaurs eventually emerged. The first dinosaur is hotly disputed. Eoraptor, Pisanosaurus, and Herrerasaurus among the possible contenders. These were very different from the other animals around them. These dinosaurs stood upright, with their legs beneath their body. Like the Rauisuchians, this enabled them to be more active compared to other reptiles, which could not breathe and move at the same time. They were also probably warm-blooded. Free from the need to get warmth from the sun, this enabled them to be active throughout the day and night. Their lungs were probably like those of birds, able to efficiently obtain oxygen from the air. Standing on two legs also enabled them to use their hands for grasping. And the first dinosaurs probably had downy feathers like pterosaurs. This points to their warm-bloodedness, and the clever use of biological systems established over 100 million years earlier. Since the development of scales, not much developmental tinkering was required to produce tufty feathers. The mammals were also experimenting with this warm-blooded with covering thing by developing hair in a similar way. Some of the larger dinosaurs seemed to lack these feathers, demonstrating a relatively easy switch from feathered to non-feathered. The dinosaurs had their advantages, but they were just one of many hopeful animals in a world of opportunity, until the Jurassic came. The end Triassic, or Triassic-Jurassic extinction, is considered one of the big 5 mass extinctions in Earth's history. Occurring about 201.3 million years ago, 23 to 34% of marine genera went extinct, including the conodonts, which had taken a big hit in the PT event and were beginning to recover, their teeth becoming an important index fossil throughout the Triassic. They were eradicated. The hardest hit, though, were the land animals, with about 42% of amphibians, reptiles, and mammal-like reptiles going extinct. Gone were the herbivorous ichthyosaurs, the crocodile-like phytosaurs, and the rauisuchids. Again, some have tried to link an extraterrestrial cause to this extinction, but all are dubious. The most likely cause was the Central Atlantic Magmatic Province, a massive volcanic event that occurred as Pangaea began to break up and the Atlantic started to form. This event was sudden, lasting about 600,000 years, releasing huge amounts of carbon and sulfur. Whatever the reason, the door was open to the dinosaurs just as the getting was good. The steady breakup of Pangaea into the supercontinents Laurasia in the north and Gondwana in the south allowed for a more temperate climate. The world became generally warm and humid. This allowed large forests of conifers, cycads, and tree ferns to develop. This new growth provided plenty of food for the new herbivores. This period is best known for its dinosaur megafauna, the sauropods. Ornithischians like the stegosaurs and early ornithopods were common, but the big movers and shakers were the likes of Brachiosaurus, Apatosaurus, and Diplodocus. These big herbivores also provided plenty of food for big carnivores, particularly the carnosaurs. Other theropods were keeping small, feeding off the small herbivorous dinosaurs and the new forms of mammals, lizards, and amphibians lurking in the undergrowth. Or they were taking to the trees and finding a new function for those feathers. The late Jurassic saw the appearance of Archaeopteryx, which many consider to be the first proper bird. The continued breakup of the continents lead us into the Cretaceous. The modern continents began to take shape, and the dinosaurs, now separated, began to diversify. Sea levels rose dramatically, and the volcanism in the seas from all this tectonic movement meant that there was a lot of nutrients and oceanic flow. The plankton had a field day and produced massive amounts of chalk. In fact, Cretaceous means chalky. The plants changed again, introducing the first flowering plants and leafy trees. Still no grass. The climate was still warm, but a lot wetter, with evidence of snow near the poles in the cooler early Cretaceous. The sauropods were replaced by the ornithopods, which had developed better feeding mechanisms, all apart from the southern continents, where sauropods remained and grew to their largest sizes. The thyreophorans had changed too, replacing spikes and plates with bony armour. The predators had to get creative. The maniraptors grew quicker, while the new tyrannosaurs grew bigger. The ankylosaurs were out in most places, but remained with the sauropods, and grew into the largest carnivores to walk the planet. The avian dinosaurs were diversifying, along with the mammals, which were getting to the point where some small dinosaurs were on the menu. For unknown reason, the pterosaurs weren't doing so well. During the Cretaceous, they were at their most grandiose and gigantic, but the number of species was in decline. Then, the third biggest extinction in Earth's history occurred. This event wiped out about 75% of all species. The large marine reptiles and pterosaurs were gone. Ammonites and a whole group of corals disappeared. Plankton and land plants were devastated. And all the non-avian dinosaurs went extinct. This extinction at the end of the Cretaceous is known as the KT or KPG mass extinction. K is for Cretaceous because the Cambrian and Carboniferous periods already had their abbreviations, and PG or T depends on whether you are referring to the Paleogene or the older tertiary naming system. The extinction of the dinosaurs has drawn the most attention. These massive, successful, diverse animals, how could they have disappeared so quickly? Dozens of theories have popped up, but I'll let you in on some of my favourite weird ones. Mammals ate their eggs. Our ancestors beat the dinosaurs. They could not eat new vegetation. A variation on this is that they couldn't properly digest it, which led to them being overcome by mass constipation. Or the opposite, overcome by mass defecation. Mass blindness, slipped discs, mass arthritis, a hormone imbalance that led to a disinterest in reproduction, and the best, hunted for food by aliens. There are various non-crackpot theories though. There was a period of massive volcanism covering half of India called the Deccan Traps. This area currently covers 500,000 square kilometres and may have covered 1.5 million, producing 3 million cubic kilometres of lava. This volcanism lasted for about 2 million years, but was at its height for about 800,000 years across the KPG boundary. Studies estimate about a 7.8 degrees Celsius rise in global temperatures because of this. There is debate about whether non-avian dinosaurs showed some decline or not before the boundary, but there is no definitive evidence of them past it. The KPG boundary across the world is defined by a decrease of Cretaceous fossils without recovery, a firm spike, as these are usually the first to recover after a disaster, and a layer of iridium with impact markers. Most of the iridium in the Earth sank into the core during its formation. This amount normally comes from an extraterrestrial source. Yes, We finally have a mass extinction with a clear indication of a bolide impact. If you map out these deposits, they indicate the impact originating around the Yucatan Peninsula. It is here that lies the Chicxulub crater. Measuring 180 kilometers across, it has been dated to 66 million years ago. Perfect for the KPG mass extinction. It came from a bolide 10 to 15 kilometers across that struck at an angle, and the impact would have been 1 billion times as powerful as the atomic bombings of Hiroshima and Nagasaki. Again, I say bolide as the thing evaporated on impact, leaving nothing of it behind. Something like that would have caused an impact wave, which would have resulted in a tidal wave. But in the grand scheme of things, if the Earth was the size of a bowling ball, the bolide would have been about the size of a grain of sand. What matters is where it hit. The Gulf of Mexico was not the deep ocean, which would have absorbed much of the impact force. The blast front and the thermal pulse of heat would have caused massive devastation on the land around the impact site. The area was also rich in gypsum, a sulfate mineral. A huge amount was vaporized and dispersed into the upper atmosphere, where it would have created an impact winter, reducing sunlight by at least 50% and creating acid rain. Freezing temperatures may have lasted for 3 years, and the sulfur cloud could have taken 10 years to disperse. The next chain of events was pretty obvious. In such conditions, the plants die, then the herbivores die, then the predators die. Total food chain collapse. No warm-blooded creature over about 25 kilograms survived, needing less food than their larger relatives. As always, big animals are very susceptible to extinction. The crocodiles and turtles were able to become dormant, using less energy and needing less food. Whether or not the non-avian dinosaurs would have died out without the impact is purely academic at this point. Not all the dinosaurs went extinct. The avians made sure that some dinosaurs survived even this mass extinction, but they would never become as dominant as their ancestors. The mammals were the opportunists this time, taking over the abandoned niches as the dinosaurs had before them. The avians, though, had the ability to fly, and without pterosaurs, made the air their primary domain, with a few reminders of their saurian past. Thank you for watching. If you like this video, show your opinion with a thumbs up and share it with others. Maybe subscribe if you'd like to see more videos like this. Why not post a comment on what dinosaur you'd like me to do a profile on next? By the way, these are dinosaur profiles. No pterosaurs or marine reptiles need apply. Note, I will not be doing Tyrannosaurus Rex in my next profile. I will be doing it eventually, I just want more experience so I can do it justice. If you want to further support this channel, I have a book available on iBooks. It's interactive, has original illustrations, and has a number of interesting dinosaurs in it. 4 from the Triassic, 4 from the Jurassic, and 5 from the Cretaceous. Link in the description. My next video will be a dinosaur profile on one of the most successful predators of all time, Allosaurus. Hope to see you then.